Let's just practice working with exponent rules. So assuming a and b are positive, x and y are real numbers, a times x times a times a to the x times a to the y is a to the x plus y. Multiplying something to a power times the same thing to that power, you add the exponents together. If instead of multiplying you divide, a to the x divided by a to the y, you get a to the x minus y. If you have a power raised to another power, a to the x, all of that raised to the y, or a to the y, all of that raised to the x, you multiply those powers together and leave it in the exponent, a to the x times y. If you have two different numbers here, both raised to the same power, a to the x times b to the x, you can combine them together as a times b, all of that raised to the x power. And in the same way, if you have a fraction of a quotient of two things, both raised to the same power, you can write as the quotient of those things raised to the x power. And so let's just apply these rules very quickly here. 3 to the 1.1 times 3 to the 0.7, same base raised to the different powers multiplied together. We add the exponents together. 3 to the 1.1 plus 0.7 is 3 to the 1.8. Square root of 10 cubed divided by square root of 10. So this one's going to be the a to the x over a to the y form, where a is square root 10. So square root 10 raised to the 3, the upstairs power, there's an implied 1 downstairs. So square root 10 squared, to the 3 minus 1 is squaring it, and that just is 10. 5 to the square root 2, all of that raised to the square root 2 power. A power raised to another power, multiply together the exponents. 5 to the square root 2 times square root 2. Of course, 5 to the square root 2 times square root 2 is 2. 5 squared is 25. 7 to the pi times 8 to the pi. Those are the same base for our exponents here. We can multiply the bases together. So 7 times 8 to the pi is 56 to the pi. And then 4 9ths to the 1/2, we can write this instead as 4 to the 1/2 divided by 9 to the 1/2. The square root of 4 is 2. The square root of 9 is 3. So this is some good practice working with some exponent rules.